The final piece in this security is networking policy. So let's say I have this cluster which has multiple pods across one or more namespaces. So the default behavior of Kubernetes is that any pod can talk to any other pod, or the communication channel is open. Let's say I have only three pods, all of them can talk to each other. So there's no isolation built in by default across pods or deployments across various namespaces. But that should not be the behavior of your production cluster. Of course, there will be specific use cases wherein you'd not like the pods or all the pods to communicate to each other because of security reasons or compliance reasons, or maybe the way you design your application. So let's say I want to isolate these two pods in such a way that the green and blue pod should be able to communicate only with the orange pod and not with each other. So this type of isolation is provided by network policies. So network policies are the ways to isolate pod communication within a cluster. Now, the way we create network policy is using kubectl, but there's a problem. Network policy is part of networking, and networking, as you know, is not implemented by Kubernetes out of the box. So when kubectl sends the command to API server, it offloads the processing of creation of network policy to the network plugin. So actually, when we try to create a network policy, the network plugin creates the policies and then sets the rule. So network policies are actually firewall rules at pod level. So by now you might be knowing what firewall rules are. I hope you have gone through the basic networking videos which I have put at the end of this course. So that's what networking policies are, or network policies are, which are firewall rules at pod level within a single cluster. Network policies cannot span multiple clusters. Now, it is supported by network plugin, but not all. Only Calico and WeaveNet supports network plugin. There are other network plugins also which support network plugin, but Flannel does not support it. So that's why we had used WeaveNet. And if you see the documentation of section 4, I have mentioned not to use Flannel because of this reason. If you use Flannel, you'll not be able to create network policies. So now let's consider a scenario. Let's say I have a cluster and there are two namespaces. One is default and the other one is prod. And in default namespace, I have a deployment wherein all the pods are labeled as green, color green. And I have another set of deployment. There's a label, let's say the label is color red. And there are multiple deployments in prod namespace. I also have a machine or server in a separate network outside of the cluster. Now here's the requirement. I want to isolate this particular pod in such a way that only deployments or pods with the label color green can communicate to it. And the machine or servers which are external to the cluster should be able to communicate to this pod as well. Now, this pod or deployment should be able to get requests or allow requests from all the pods in prod namespace. So there's no deployment level or pod level filtration there. What I'm saying here is that all the pods in the entire prod namespace should be able to communicate with this particular pod. And this pod or deployment or pods inside the deployment should be able to send requests to all the pods in prod namespace. So there are various things here. I have shown you machine or server outside of the cluster. I have talked about labels, namespaces, clusters, and various colored communication. So now the communication or the arrows which are in blue are ingress or inbound requests, and the one in maroon are egress or outbound requests. Now when we create a network policy, we have to take care of all these things. Now how do we take care of the pods which are in the same namespace and pods which are in a different namespace? For that matter, machines or servers which are outside of the cluster altogether. And along with that, we have to take care of ingress and egress requests or inbound and outbound requests. So how do we handle all these things in a single network policy? So there are a few things that you have to remember. The Pods inside of the cluster are filtered by something called pod selector in the network policy manifest file. Then we can filter out a complete namespace using something called namespace selector. Then if we have a machine or server in a different network altogether outside of the cluster, we can filter them out using IP block and CIDR keywords in the manifest file. So considering all these like IP blocks and CIDR, pod selector, namespace selector, ingress and egress, let's see how do we create a network policy manifest file. The reason I'm showing you this because by far network policy manifest file is one of the most complicated, and add YAML syntax on top of it, of course it becomes very confusing. So let's see step by step. The first thing is of course the API version, kind and metadata, which you already know, and this should be there. The API version is networking.ktest.io/v1 and the kind would be network policy. And in metadata you can mention name and labels also. Then you have spec or specifications. Now the specification for network policy is really big. The first thing is the pod selector. Now we have pod selector and we have match levels. We can have match expressions also, which you already know. Now using this pod selector, this particular network policy will be applied to all the pods which match this pod selector criteria. So using this pod selector, we are saying that apply this network policy to all the pods that match this match labels criteria. There's one more pod selector later on, so I don't want you to get confused with both of them. So just after spec, the pod selector that we mentioned is used to apply the network policy to all the pods. Then we have policy types, whether we want ingress or egress. If you know that your network policy would contain both ingress and egress, then you should mention both, or else any one of them, whichever you want to create. Because I'm creating network policy for the red pod in the previous slide, will have both ingress and egress. Then we specify ingress, which actually is part of network policy specification. Now this ingress should be indented with the policy types. So this particular line should be here just after this. It should be indented with the policy types. Okay, let's see ingress in a little bit more detail. So the first thing is from, and we can mention multiple from statements, as you can see, because it is an array. Now inside of the from also we can mention multiple selectors. The first one is the IP block, wherein we can mention the CIDR block. Now this is needed or to allow machines or servers which are outside of the cluster and in a different network. That does not necessarily mean that you have to have it, because you might not have a scenario wherein you need to allow servers or machines from outside of the cluster, but if you have to, then you'll use IP block. Then we have pod selector again. Now this pod selector is not the same as this one. Now this pod selector is inside of the ingress. That means that select all the pods which match these labels, or which match labels, and put them in the filtering criteria. That means we are allowing only those pods which match this criteria to communicate with the pods to which this network policy is being applied. Let me repeat, this pod selector is actually filtering the pods which are allowed to talk to the pods to which this network policy is being applied, and this pod selector is for those pods to which this network policy is applied. So the pods which are filtered by this match labels condition or this pod selector condition will be able to communicate with the pods which match this pod selector condition. Then the next one is the namespace selector. So we can select the entire namespace, and we have to select the namespace using match labels also. So far we have not mentioned any labels to our namespaces, but in this demo I'll show you how to do that. So all these three conditions, IP block, pod selector and namespace selector, are for different filtering condition. IP block is to filter the source which are outside of the cluster. Pod selector are for the pods which are in the same namespace, and namespace selector is to select the namespace. Then we mention ports. In ports we mention protocol and port, and we can have of course multiple ports. Then the egress. Egress talks about where these pods would be able to send communication to. Now here again we can mention IP block, port selector and namespace selector, just like from. But here I have just mentioned namespace selector with match labels. And similar to ingress, we can mention ports with protocol and port. So ingress and egress are more or less similar, the only difference being the from and to keyword, and the remaining things are same. So that's how network policy works. And as I said, it's a little complicated than any other manifest file that we have seen so far. So there are essentially four blocks in this network policy specification. The first one is the pod selector, which is this one, which talks about the pods to which this network policy will be applied. Then policy types, whether this network policy would contain rules only for ingress or egress or both. In this case, it is for both. Then the ingress block, wherein we mention the source from where communication would be allowed. And then the egress block, where we mention the destination to which the communication would be allowed. So this is how a network policy manifest file looks like. Let's head over to the demo.